Hello, this is checkpoint 3.18 from section 3.3. We have this function g of x is equal to 1 over x to the 7th, and they want us to use the extended power rule to find its derivative. Now, the power rule is the same whether you call it extended or not, but technically they're extending it because when they first proved the power rule, it only worked for positive integers. So now they're saying that this could also work for negative integer powers. So if your p is, it's not 1, 2, 3, 4, 5, the positive integers, but if your p was equal to negative 7, like in this case, then you can also use the power rule the same way. Okay, so what we'll do is we'll take our function g of x, which is equal to 1 over x to the 7th, and let's rewrite it as x to the negative 7th power, because that's what the power, that's what the rules for exponents tell us. So now if we want the derivative of this, we'll just treat negative 7 as if it was p. So g prime of x is going to be negative 7 x to the, now we have negative 7 minus 1. So this is where you have to be kind of careful when you're doing the power rule, especially with negative numbers and sometimes even with fractions. Now we can't do fractions yet, but we'll see that we can also do fractions with the power rule as well. But technically in this section we can't do it yet, so let's stay away from fractions. But you just have to be careful when you have a non-positive integer as a power when you're subtracting 1. Anyways, g prime of x will then become negative 7x to, now negative 7 minus 1 is negative 8. So that is our function. It's hard to see, so let me rewrite it. Now you can leave it like that, that's fine. Again, I wouldn't care. I think this is as good as an answer as this next one, but sometimes people would prefer positive exponents, and so this would be x to the 8th power. And sometimes when you're manipulating it, it might be worth it to rewrite it as a fraction, because to try to get a clearer picture of what's happening. If you need to solve for something, it might be good if you're working with a fraction. Okay, in any case, this is the derivative of this g function. I hope that helps.